And we'll just write this first one. And we have a property that says if you can make the bases the same, then you're allowed to set the exponents the same and drop the bases. So what you're going to try to do is write the bases the same. Right, and so 10 is already good. We want to see if we can write 1,000 as 10 to a power. And I believe that is 10 to the third. So you'll have your calculator just to play a little bit. And we'll test 10 to the third. Is that 1,000? Yes. So that allows us to rewrite that right-hand side in terms of 10 to a power. And once you have the bases equal, then you can drop those and set the exponents equal and solve. So n equals 3. This one is actually already solved for us. And this was 10. All right, we'll do one more on this page. So 11, we have 64 to the x and 256. Our goal is to try to write these as something to the power, and we want the same base. I am thinking we go down to 2. I mean, there are other things. This is 8 squared. It is 4 to a power, but I think both of them are 2. And so you just verify that on your calculator. So 2 to the 5th is 32. So I believe 2 to the 6th is 64. All right. And then we have to test 256. So we make a guess. Let's see. We had 2 to the 6th. So let's try 2 to the 8th is 256. Right, so we do have the same base. With your exponents here, it will be power to a power, keep the base, and multiply. So this we can rewrite as 2 to the 6x equals 2 to the 8th. Now you have the same base. So you're going to drop that base off, set these exponents equal, and then you will have an equation that you're used to solving. So you're going to divide by 6. And you should reduce. This has a common factor of 2. So we'll go into 8, 4, and 2 will go into 6, 3. And you could reduce on your calculator.
Quick question.
Yes.
So I know you said like just kind of like to mess around with it a little bit, but like how did you know to go to like 2?
Okay. Actually, because I remembered that 2 to some power, so that doesn't help you a lot. You're just going to make some guesses.
Okay.
And see what works. It has to be something, of course, that goes into both of those. And your choice of things to a power, 64 had more. It has 4 to the 3rd is 64. So if we wanted to try that, because that would be okay on this side, but we would have to see, okay, is 4 to some power. All right, there's 4 to the 3rd. Whoops. There's the 64. So if I try 4 to the 4th, so I could have gone with the 4. Okay, excellent point here. And we should get the same answer, though, at the end. So 4 to the 4th is 256. Right, and this will multiply. So you have 4 to the 3x equals 4 to the 4th. Once the bases are the same, you are going to set the exponents equal. So 3x equals 4, and solve. And so you're going to divide by 3. So x equals 4 thirds. Okay. So there's more than one way when you get there. I think some of the others, it'll be a little bit more obvious to you of what to try as something to a power.
Thank you.
And please ask me again. That's such an excellent question because you can see here that you could have used 2 different ones. They just have to end up the same on both sides. All right, let's get the calculator out of the way. The next one you have to isolate before you can do this. So 12. You need to isolate that power part that is to a power. So first we need to add the 3 to both sides. So 3 times 5 to the x equals 375. You're going to divide out this 3. So you have 5 to the x equals, and that just goes to your calculator. And I transpose those numbers. Let's try again. 375 divided by 3. 125. All right, so once you have this piece isolated, this one is more obvious what you're going to use because on the left, I mean, that's a prime, so you have to use the 5. So you're going to try to see, okay, how about writing this as 5 to some power? And you know probably that 5 squared is 25, so if we try 5 to the 3rd here, there's our 125. So this one is set. This one is 5 to the 3rd. And now you just set these exponents equal. So x equals 3, and this one is actually already solved for you. Any question there? You do have to isolate that exponential piece first on that. Right. This next one has something in a fraction form, and you really don't want to deal with that. So what you can do is to work on this, to get a number in the denominator, remember it's to a negative power. So this 1 over 10 is really 10 to the negative 1. That's the same as 1/10. We would rather use this form, not the fraction form. All right, this is to the x power, and then we'll try to see, okay, 10 to what power is 1,000, and I believe it is the 3rd.
It's 10,000, not 1,000.
Okay. Sorry about that. So it will not be the 3rd. But we'll just try. So 10 is what we're going to try for the base. So if we try 10 to the 3rd, that is going to be your 1,000. So 10 to the 4th is going to be your 10,000. Yes. And this just is going to give us negative x. So we have 10 negative x equals 10 to the 4th. And now you can set these exponents equal and solve. So you'll have negative x equals 4, divide by negative 1. So x is going to equal negative 4. And this one, I was not looking at it close enough the first time I looked at it, and these amount of zeros are not the same. Okay. So I was just saying this is to the -1, but that's not true because this one has 3 zeros and this one has 4 zeros. So I would go with 10 to some power here, and this one is 10 to the third, which will give us 10 to the 3x. This one, because it's in the denominator, it'll be a negative power, but we can just play with our calculator. So 10 to the 4th, and we actually did that on the other one. So this time, though, it will be negative because it's in the denominator. So it will be 10 to the -4 is what moves it down there. And so here, this will be 3x. So we have 10 to the 3x equals 10 to the -4. And now you have the right setup. So set your exponents equal. And then divide by 3. So x equals -4/3. Right. This one will do. Just the solving is going to be a little bit more work and a place to be careful. But it already has the basis the same. So it's already set up. All you have to do is set these equal. So x plus 3 will equal 7x minus 8. And now you have a linear equation. So I'm going to get rid of the x. So 3 equals 6x minus 8. Add your 8. So I get 6x equals 11 and divide by 6. So x equals 11 over 6. If you started the other way and got rid of 7x, you should get the same answer. So it just looked like it would be harder. It actually was not a big deal. Right, let's look at this one. So 49 x plus 3 is 343 to the x minus 2. So you're going to have to pick something that's to a power. What do you think you're going to try for your base?
7?
7, exactly. Because 7 squared is 49. Now you have to test, does 7 to some power equal 343? But that really is your only logical choice. So we'll just try for, let's see, let's just try 7 to the 3rd. Let's clear that out. So 7 to the 3rd is the 343. So this is 7 squared and this is 7 cubed. Right, and I did want you to see this particular one because you have to remember here that your exponents are going to multiply. You're going to need to throw parentheses on those binomials when you bring them down. So you're going to have 2 times x plus 3, and here you're going to have 3 times x minus 2. So that's the piece that you will need to remember there. And then it's regular. So 2x plus 6 and 3x minus 6. Right, so if I get rid of the 2x, that's 6 equals x minus 6. So I'm going to add a 6. So x equals 12. Good. So just be cautious here, especially if you have a binomial, because this will multiply parentheses. That's what you need. Right. 17 I'm going to skip. You're going to write that one as 3 to a power, and this will just be 3 to the negative 4, I believe. And then you'll set them equal to solve. Right. And we'll try this one. Need to make sure that I save just a few minutes for those word problems. And they're actually easy word problems because all you do is plug in to a formula, but we need to do a couple. All right, so 216 x minus 3 and 1 over 6 to the x plus 3. All right, I think you're going to have to work with a 6 here because there's nothing else to a power that's going to give you 6. So this one I'm going to change as 6 to the negative 1. And that is to the x plus 3. So I'll have to check on 6 to what power. I believe it is the third. Is 216. So 6 to the third. And then you can set these equal, but you'll need parentheses. So you have 3 times x minus 3 and negative 1 times x plus 3. And then you're going to solve. And I'm going to skip the solving from there and give you the answer. And you can play with that later when you get to the problems. But that was the pieces I wanted you to see. All right, I'll do one more of these, and then we're going to go to the word problems. These last couple just give you a quadratic equation instead of a linear equation. These are linear equations. Isolate the variable, right? Quadratic equations, they should probably all factor and use the zero product law, but this first one is not very nice, really, so we'll do it. Right, so really your candidate here is to try to write 5 to a power is 625, and it is to the 4th power. For 625. All right, so this will keep. And that's your setup that you need. Now you're allowed to set the exponents equal. All right, so seeing the exponent of 2, that's what's different here. And so I am going to change this to descending order and move the 4 over. So negative 25y squared minus 25y minus 4 equals 0. I don't like a quadratic equation to start with a negative, so I'm going to factor the negative out. It's going to change all my signs. All right, and I'm going to go ahead and divide by negative. Now, recently we did the polynomial inequalities, and when you divided by negative, it had to flip the sign. But that was because it was an inequality. With equations, dividing on both sides by negative 1, 0 divided by negative 1 is still 0. So it is not going to affect it at all. It's just going to make our factoring hopefully a little bit easier by dividing that negative 1 out. So we're here. And when I've looked at this, I thought it would be a perfect square trinomial. Remember where you take the square root of the first one and the square root of the last one, and you guess those? When you try that, though, it doesn't work out when you check. So that was my first thing that I thought, okay, I'll try this. but you have to check and make sure the middle works. And outside gives us 10y plus 10y is 20y. It is not 25y. So perfect square trinomial did not work. So I said, okay, we have to go with trial and error. And I don't want to play too long with it because I could always go to quadratic formula. All right, but I said, okay, let me try the 5 again and see if I can try 4 and 1 here instead. And it actually worked. And so I didn't try a lot. So there is 5y on the outside plus 5y plus 20y gives us 25y, which is what we want. Then we can set each piece equal to solve. So 5y plus 4 equals 0. You're going to subtract your 4. So 5y equals negative 4 and divide by 5. So y equals negative 4/5. This one, 5y plus 1 equals 0. Subtract your 1. So 5y equals negative 1 and divide by 5. So negative 4/5 and negative 1/5.